गार्ड लगाएगा।
अगर आप लोग व्यवस्था कर लो तो कोई बात नहीं, आप कर लो।
हेलो हेलो
हमें क्या आ रही है? डाइट लगा रही थी।
लगी हुई है। एक चैनल बंद कर दीजिए।
हेलो
सर यहाँ क्या होने वाला है बताओगे एक बार।
नीचे कर दे तो बंद हो जाएगा।
नाम यहाँ पे किसी और का डाल दिया।
दो नंबर पे।
हेलो हेलो
आपका मारिए। क्या नाम
बलराज सिंह।
क्या बताया हमारे पास क्यू शीट में जो बनी आईसी अग्रवाल है।
ऐसे अग्रवाल इस साल इसमें कहीं खुला ही नहीं। हेलो देखो सुनो। हेलो 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 1 2 3 चेक हेलो हेलो 1 2 3 चेक 1 2 3 चेक हेलो 1 2 3 चेक कम आ रहा है ना पहले से हेलो बाहर जाके सुनो हेलो 1 2 3 चेक
डायरेक्ट डायरेक्ट
हेलो हेलो 1 2 3 चेक अब ठीक आ रही है ना एक बार और चेक कर ले हेलो 1 2 3 चेक ये यहाँ की वॉइस भी आ रही है इसमें चलो छोड़ो इससे बेटर नहीं कर सकते हाँ आता है आ रही है ना इसकी हेलो 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 तो इससे ज्यादा क्या जान लोगे
हेलो।
अगर वो बस सिनेरियो अगर हुआ होने देना नहीं।
मेरी बात सुनो जरा। जैसे यहाँ पे किसी सेक्रेटरी आए, उसके पास जाइए, चेक कर लेना कि कौन है यहाँ पे। पूछ आना नाम है कौन है।
और ये बैठा है अमन क्या मत रूम
अरे मुझे नाम नहीं मालूम सेक्रेटरी से।
पहले ये फिर मैंने क्यों पता है
अरे वो कौन नहीं मिलेगी।
ओके ऐसे इशारा कर देना ऐसे इशारा कर देना अगर पॉजिटिव होगा ना ऐसे कर देना
कायो पहले इनमें वीडियो को चला
नहीं वो कौन सेक्रेटरी का नाम बता। सर हिमांशु आ गया।
गणानाम गणपति गणेश लंबोदर सोहे भुजाचार एकदंत चंद्रमा ललाट राजे ब्रह्मा विष्णु महेश तालदय धुरपत गावे अति विचित्र गणनाथ आज मृदंग बजावे मृदंग बजाए।
चेक करो. हेलो. Good morning, everyone. I am Asa Dhadij, and it's my pleasure to welcome you all to the insightful session of Tech Connect 2024. And today we have the privilege to hear from our highly esteemed speaker, Mr. IC Agarwal, who is non-executive chairman at Genus Paper and Board Limited, who will be delivered some session on the topic bridging the skills gap in semiconductor manufacturing and strategies for inclusive in the workforce. Let me take a moment to introduce our speaker, Mr. IC Agarwal. He is currently serving as a non-executive chairman at Genus Road Paper Limited and executive chairman at Genus Power Infrastructure Limited. He has also served as director at Yazoo Coal and Coke Limited. He is also on board of director at One Auto Logistic Park Limited, to Genus Electrotech Limited, Genus Innovation Limited, Genus International Commodities Limited, Genus Paper Product Limited, and many more. Now we come to very special moment of our session to honor our esteemed speaker, Mr. IC Agarwal. I would like to invite on stage our respected Mr. Vijay Chatterjee to kindly felicitate our guest with a memento. And Mr. Mahesh Mundele, sir, on stage. Sir, please. Thank you so much, sir. Now, without any further delay, I would like to invite Mr. IC Agarwal to take over and share his insight with us. Please join me in welcoming him with a big round of applause.
नमस्कार। टेक कनेक्ट 2024 जिसके लिए ये आमंत्रित किया गया है, इसमें मुख्य जो मुद्दा है वो स्किल डेवलपमेंट का जो रखा गया है, और जो सेमीकंडक्टर के ऊपर जो एक विचार गोष्ठी ही कहूँगा, विचार गोष्ठी रखी गई है। क्या थोड़ा ऐसे बताया नहीं गया था। तो इसका ये जो विशेष सत्र है कि अभी सेमीकंडक्टर की अपने हिंदुस्तान में पहली बार यूनिट्स आ रहे हैं जो वेफर्स बनाएंगे, जो आगे सेल बनाएंगे, आगे उनका जो भी कार्य होगा उसका अभी स्किल डेवलपमेंट हमारे यहाँ जो अभी अनुभव की कमी है, तो इसके लिए कॉलेजेस में नए जो है आयाम शुरू किए जाएंगे। आज की इस विशेष सत्र में मुझे ब्रिजिंग द स्किल गैप इन सेमीकंडक्टर मैन्युफैक्चरिंग स्ट्रेटजी ऑफ इंक्लूजन इन वर्कफोर्स पर अपने विचार साझा करने का अवसर मिला है, जिसके लिए मैं बेहद आभारी हूँ। ये विषय न केवल उद्योग के विकास से जुड़ा है, बल्कि सामाजिक समावेश और राष्ट्र की प्रगति में सीधे तौर से जुड़ा हुआ है। सेमीकंडक्टर निर्माण उद्योग तकनीकी जटिलताओं से भरा हुआ है और इसके लिए एक अत्यधिक प्रशिक्षित कार्यबल की आवश्यकता होती है। हमें समझना होगा कि इस उद्योग में कौशल अंतर को भरने के लिए व्यापक और समर्पित प्रशिक्षण कार्यक्रमों का विकास अत्यंत आवश्यक है। शिक्षा संस्थाओं और उद्योग के बीच साझेदारी के माध्यम से हम ऐसे पाठ्यक्रम तैयार कर सकते हैं जो इस क्षेत्र की उभरती आवश्यकताओं को पूरा करे। साथ ही कर्मचारियों की अपस्किल करने के लिए ऑन द जॉब ट्रेनिंग और निरंतर शिक्षा का भी महत्वपूर्ण स्थान है। हमें यह सुनिश्चित करना होगा कि सेमीकंडक्टर उद्योग में कार्यबल केवल तकनीकी रूप से सक्षम ही नहीं हो, बल्कि विविधता से परिपूर्ण भी हो। महिलाओं, समाज के वंचित वर्गों और अलग अलग भौगोलिक क्षेत्रों के लोगों को इस उद्योग में शामिल करने के लिए हमें सक्रिय रणनीतियां अपनानी होगी। समवेशता केवल नैतिक जिम्मेदारी ही नहीं, बल्कि ये उद्योग के नवाचार और विकास के लिए भी आवश्यक है। इस कौशल अंतर को भरने में उद्योग, शिक्षा जगत और सरकार की सामूहिक भूमिका बेहद अहम है। उद्योग को न केवल रोजगार के अवसर उपलब्ध कराने चाहिए, बल्कि कौशल विकास में भी सक्रिय भागीदारी करनी चाहिए। शिक्षा संस्थाओं को इस उद्योग के लिए तैयार करना और उनके लिए मिलकर प्रासंगिक पाठ्यक्रम विकसित करना एक महत्वपूर्ण कदम होगा। साथ ही सरकारी नीतियां और प्रोत्साहन योजनाओं के इस प्रयास को मजबूती देगी। आज का यह सत्र हमें इस बात पर विचार करने का अवसर प्रदान करता है कि हम कैसे एक ऐसे समावेशी कार्यक्रम का निर्माण कर सकते हैं जो न केवल सेमीकंडक्टर उद्योग की बढ़ती मांगों को पूरा कर सके, बल्कि देश की समृद्धि में भी योगदान दे सके। विविधता और समावेशिता के साथ कौशल विकास भी इस उद्योग की असली शक्ति बनेगी। मुझे पूर्ण विश्वास है कि हमारी चर्चा से ठोस समाधान और रणनीतियां निकलेगी जो इस उद्योग को कौशल समृद्ध और समावेशी बना सकेगी। देखिए, तो एक लिखा हुआ मैंने जो सुनाया है, मुख्य बात ये है कि हमारे देश में पहली बार सेमीकंडक्टर की जो है बड़े उद्योग आ रहे हैं, जो अभी गुजरात में जो 3 MOU हो चुके हैं अब तक, और मैं समझता हूँ कि 2027 तक ये इनके प्रोडक्शन, वैसे 26 की बात करते हैं, लेकिन 27 तक तो ये प्रोडक्टिव हो जाने चाहिए। लेकिन अभी इसमें स्किल की बहुत आवश्यकता है। अभी तो सारे जो है चिप्स जितने भी ये सब इंपोर्ट होते हैं, जब वेफर चिप्स यहाँ बनेंगे तो उसके लिए स्किल चाहिए, और स्किल उसको हर जगह चाहिए। तो उसके लिए अभी बहुत अच्छा स्कोप है। तो मैं ये कॉलेज अगर इस तरह के पाठ्यक्रम कार्यक्रम चलाते हैं तो और उद्योग से सहभागिता चाहते हैं तो ये बहुत एक अच्छा कार्यक्रम है। और हमारा चूंकि इलेक्ट्रॉनिक्स का ही फील्ड है, जीनस पावर कंपनी जो है वो ऑटोमेटिक मीटर रीडिंग सिस्टम में है, और हम लोग MISP मीटर्स बनाते हैं। और हमारे उद्योग में ये समझिए कि इस समय हमारे ग्रुप में इस उद्योग में 10,000 लोग काम कर रहे हैं, और 5,000 लोग हम आगे आने वाले 2 साल में और लेने वाले हैं। तो इसी से रिलेटेड हमारी जो है कंपनी है। तो मैं समझता हूँ कि आप लोग इसके ऊपर पाठ्यक्रम को जो बनाने वाले हैं, इसको टेक्नोलॉजी को जो बनाने वाले इंस्टीट्यूट्स हैं, वो आपस में साझेदारी करके अगर इसको विकास करेंगे, बढ़ाएंगे, तो ये अपने आप एक बहुत अच्छा जो है देश को आगे बढ़ाने का कार्यक्रम होगा। और स्किल बढ़ेगी तो देश बढ़ेगा, क्वालिटी बढ़ेगी तो देश बढ़ेगा, और देश के लिए हम लोग सब मिलकर काम करेंगे। हमारे कोई भी देश को तीसरी जो आर्थिक हम चाहते हैं कि जो हमारी बने आने वाले टाइम में जो है व्यवस्था, उसको कोई नहीं रोक सकता। बहुत बहुत धन्यवाद। थैंक यू।
Thank you so much, sir. I'm sure everyone has gained a lot of valuable insight and knowledge from this valuable session. Now, we would like to open the floor for questioning. If you have any queries or need further clarification on any of the topic discussed, please feel free to ask.
Does anyone have any kind of question regarding the session?
Please raise your hand for questions. No? Thank you. Please feel free to ask.
Hello. Dear students, the personality which you are having right now, it's a very rare chance that you will be getting this kind of people around here. So it's your golden opportunity to ask your queries because ultimately you are supposed to chase your career. So he's the best person to reply, at least in the industrial sector. So I would request you to ask few questions before we start the panel discussion.
As we come to close of this insightful session, it's time to express our gratitude to all those who made this event possible. To do the honor, I would like to invite Dr. Shantanu Malik, Associate Professor, Department of Civil Engineering, to deliver the vote of thanks. Sir, please.
Thank you, Asta, for inviting me. As we conclude the first session on bridging the skill gap in semiconductor in manufacturing, strategies for inclusion in the workforce, I take immense pleasure to extend a heartful vote of thanks who made this event a successful one. Firstly, I would like to express my gratitude to Mr. IC Agarwal sir, who shared his insight and enriched us through his speech. I also extend my appreciation to all the organizing committee and all the volunteers who have worked tirelessly to make this session a successful one. Thank you all.
Please be seated. Next panel discussion will be starting.
Audible to you?
Good morning, ladies and gentlemen. A very warm welcome to Tech Connect 2024 at Purnima College of Engineering, Jaipur. It's an honor to have a distinguished gathering today filled with innovators, scholars, and future leaders. Today, we have with us Honorable Dr. Suchandan Pal, Chief Scientist, CSIR, CEERI, the moderator of the session. Respected guests, Sri Alok Gandhi, Joint President, International Business, CEG, Dr. Deepak Bhatia, from Electronics Engineering Department, Dr. Manoj Saxena, Professor, Department of Electronics, Deen Dayal Upadhyay College, University of Delhi, connected to the virtual mode. Respected organizers, coordinators, the technocrat present over there, and of course the fantastic audience. On the behalf of entire PC fraternity, we offer you the most graceful hello and welcome. Before we begin, let's extend our gratitude to the dignitaries we have joined us today, and we are deeply honored to have their presence and support. And now it's time to introduce the esteemed individual leading today's panel discussion, Dr. Suchandan Pal, Chief Scientist, CSIR, CEERI. We are thrilled to introduce our moderator, Dr. Suchandan Pal, who holds a BTech and MTech from Institute of Radio Physics and Electronics, University of Calcutta, and completed his PhD at City University, London. He joined CSIR Central Electronics Engineering Research Institute in 1995 as a scientist. His research area includes photonic device design, triple-I nitride materials, waveguide drafting, photonic crystal, and in-GaN AI GaN-based LEDs and sensors. He has led significant national projects and published over 150 papers. Dr. Pal is a life fellow of the Optical Society of India, IETE India, and IEEE, and a life member of Indian Physics Association and Semiconductor Society of India. So I request everyone to please give him a huge round of applause. And along with this, I request Dr. Anju Gautam, Associate Professor from Purnima College of Engineering, to please honor our respected moderator with a token of respect and appreciation. Please, ma'am. Today we have with us the distinguished panelist Shri Alok Gandhi, who is having an overall experience of more than 23 years. He is having the specialization as an engineering consultancy for design and supervision of highways, water supply and drainage, town planning and urban infrastructure, railways, airports, technical advisory, and procurement assistant. He has business sense and aware of environment for regions like Africa, CSI countries, and Southeast Asia. I request again to please give him a huge round of applause. Sir, we welcome you. We have with us Dr. Deepak Bhatia, Electronics Engineering Department, the Associate Professor in Rajasthan Technical University, Kota, with 17 years of teaching and research experience. His research interests include wireless and mobile communication system, and nano-thin films, MEMS cantilever sensors, MEMS energy scavengers, RF and microwave communication, advanced antenna systems, and IoT. He has published more than 80 research papers in international esteemed journal and conference. Sir, we welcome you. I request everyone to please give him a huge round of applause. We have with us Dr. Manoj Saxena, Professor, Department of Electronics, Deen Dayal Upadhyay College, University of Delhi. He has done MSc and PhD in electronics from University of Delhi. He is currently a professor in the Department of Electronics, Deen Dayal Upadhyay College, University of Delhi. He has authored or co-authored around 350 plus technical papers in Scopus Index, international journals, and conference proceedings, and has delivered 40 plus IEEE EDS distinguished lectures. His research area and mathematical modeling and TCAD simulation of nanotech electronics devices. He is a fellow of National Academy of Sciences India, a fellow of the Institution of Electronics and Telecommunication Engineers India, and the Optical Society of India. He is the senior member of IEEE, the member of Institute of Physics in UK, and the member of Institution of Engineering and Technology UK. Sir, we welcome you. Thank you for giving your time through the virtual mode. I request everyone to please give him a huge round of applause. Now I request the moderator of this panel discussion, Dr. Suchandan Pal, Chief Scientist, CSIR, CEERI, to please felicitate our respected guest, Shri Alok Gandhi, Joint President, International Business, CEG. Please, sir. Sir, we welcome you. Please accept our token of respect. Again, I like to request Dr. Suchandan Pal to please welcome with a token of respect and appreciation Dr. Deepak Bhatia, Associate Professor from Electronics Engineering Department. Along with this, I would like to request Dr. Suchandan Pal to please felicitate and welcome our guest Dr. Manoj Saxena through the virtual mode and also proceed the session. Please, sir.
Good morning, Dr. Saxena.
Thank you very much.
You have joined through online. We all welcome you on this session. We are missing physically over this session, but nevertheless, we'll have our discussion, and great to have you in this discussion.
Thank you very much, sir.
Welcome for this panel.
So I hope I'm audible to all of you.
Thank you so much, sir. I request you, sir, to please proceed the session. Please, sir.
By sitting,
In which you are comfortable, sir.
Very good morning to all of you. Very good morning to all panelists joining in person, and Dr. Saxena joined through online. I welcome all of you. Here Dr. Bhatia is here, and Dr. Gandhi is here with me. And today we'll discuss a very important topic have been given to us for panel discussion. The topic is bridging the skill gap in semiconductor manufacturing, strategies for inclusion for the in the workforce. And there are few proposed topics on panel discussion. I just go through. Maybe within very short time, all these topics may not be possible to discuss. First one is what strategic partnerships between semiconductor industry and government agencies can be formed to develop and fund training program that specifically target skill gaps and promote workforce diversity. Number 2 point is how can government regulations and incentives be leveraged to encourage semiconductor companies to adopt best practices in workforce diversity and inclusion, particularly in training and recruitment efforts. Third point is also related to that. What role should government play in establishing industry-wide standards for training and certification in semiconductor manufacturing, and how can these standards promote inclusively and skill development for underrepresented groups? So all those are very wide topics, and as far as semiconductor skills are concerned, that is particularly very important in the context of initiative of India Semiconductor Mission that all of you heard about that. I just will discuss for the audience. I'm just this is the background that we'll discuss. You all listen to the discussion. You may have some queries, and after the end of the discussion, you ask your queries to the panelists, and that may be clarified to some extent. So, before the start of the panel discussion, I very briefly give the background that India Semiconductor Mission has started or initiated 3-4 years back, when in December 2021, Cabinet Ministry they announced for the semiconductor and display manufacturing ecosystem to create within the country, and with the overlay of total 76,000 crore over the period of 6 years. There are few objectives on strong semiconductor ecosystem in India, indigenous development of semiconductor design and manufacturing, fostering collaboration between industry, academics, and research institutes, promotion of skill development and talent acquisition in the area of semiconductor, attracting investment, and driving innovation in semiconductor technology. So all are very important points and very much interrelated. And over 3-4 years, there are series of conferences on Semiconductor India happened all over India. First one in Bangalore in 22, then New Delhi, then Gandhinagar, very recently in Noida, Greater Noida. Series of conferences happened. All are related to how ecosystem within the country can be created for semiconductors and allied systems, and related things for the supply chain. As you know, that all the raw materials and everything we are importing for semiconductor device fabrication. And most importantly, we are talking about that creation of semiconductor device fabrication manufacturing, including ATMP, that means assembly, testing, marking, and packaging, and OSAT also. OSAT means outsourced semiconductor assembly testing. So all those we are planning within our country, but where is the workforce? Where is the manpower? As per our experience also, what we have seen, that all the students, manpower, they have very much talent. They have gone through or gained very much very good theoretical knowledge. But whenever it comes for the hands-on training, particularly in the area of semiconductor, they are uh, very very much less exposure they have. And it is obvious because that type of opportunity or scopes within the country we don't have. And that's why the session is here. We are conducting the session. Where are the gaps? Where are the opportunities? Where are the challenges? How this gap can be bridged? And within the panel itself, we are having eminent personalities from various organizations, including CEG, including policymakers, academic institutes, R&D organizations also. So, although another there is a gap at this moment itself, we were expecting at least 1% from the industry as well, because the industry feedback in this regard is also very much important. Nevertheless, we'll go in round. I will circulate the microphone to all the panelists to make their view. Maybe maybe around 5 minutes, and after that, if required, we will go for the second round of very quick discussion, and after that we will conclude and take any queries from the audience, if any. So with this background, I just now hand over to Dr. Bhatia to give his view in this aspect.
Thank you, Dr. Paul.
Thank you, Dr. Paul.
As
all of you know, that we are
in
the process of panel discussion on the topic that bridging the skill gap in semiconductor manufacturing.
I think
as told by the administration of TCE, that audience is mix of all the kind of students like BTech, MBA, MCA. So let us know how this semiconductor mission of India is important to us. Why this issues has been addressed by our Honorable Prime Minister in 2021. You know, there we faced a very big challenge or very big problem of chip shortage. Chip shortage in 2021-22. So the delivery of the vehicles, four-wheelers, was braked due to the chip shortage, because most of the chips we acquire from the Taiwan and China. So our dependency on this semiconductor chips is more and more on other countries. To fill this gap, to make our country a leader in this, because this type of production can govern our economy also. This is a cutting edge technology, can drive the economy of any of the country in the world. So how this semiconductor manufacturing is important to us? Our government has taken some of the initiative, but still there is a gap between the trained or skilled workforce. because our country is developed in the
process
process
of
of making Viksit Bharat
in
in up to
2047.
2047.
We are under
We are
developing
under
stage.
developing
So
stage.
there are a
So
lot of
there are a lot of
challenges in our
challenges in
policies
our
also.
policies also.
So how
So how
we can fill
we
this
can
gap?
fill this gap?
I have some
I have some
suggestions.
suggestions. I think you have also some suggestions.
So we will take
So we
one
will
by
take
one.
one by one.
There
There must be a more interaction between
academia
academia
and
and
industries.
industries.
Because
Industries knows
what is the actual
what is the
requirement.
actual requirement.
Educationalists
Educationalists or academicians
can
can provide
the
the academically
sound
sound professionals,
but they
but they cannot work in real time.
because
Because I have seen this type of
fabrication
fabrication lab
at
at IIT
and
Bombay
ISC
and
Bangalore.
ISC Bangalore.
I did
I did
fabrication
work
at these
at
places
these places in
my PhD.
my PhD.
So
So I know
what is
what is the cost of running these type of labs, fabrication labs.
So
So we know the
trained
trained, skilled persons
that
that may cope up the demand of the industries. Government
is in
the process to attract
the leading
the leading manufacturer of
semiconductor
semiconductor in the world.
They are
They are giving some relaxation
to
to these type of industries to come in at the India and start their plant. Some of the industries has started their plants at the Ahmedabad, in Gujarat. But still we are lagging because there is
a huge
a
gap
huge gap between
demand
demand and the supply. If some of the industrialists establish their labs or manufacturing plant, we are still now we are not in the position to provide the skilled manforce. So I think from the diploma level, we should start some of the courses. Definitely they will give a huge employment in our country also. And at the engineering and post-graduation level, our research should be a device productive.
right
Now, our research is just only to publish the papers, but at the end of our research, we are not able to provide any kind of device.
so this is a
So this is a huge gap. And
in the
in the initial stage, government may provide some more relaxation in land, in the government policies to attract these type of industries. And there should be a more and more interaction between academia and industrialists.
we can
invite industrialists
who
who are really working in such type of industries, semiconductor manufacturing, to guide or to train our students or to train our workforce.
so
They will at the end of their training, they will be able to fill this gap.
so
With these words, I am giving
this
this mic to industrialist among us, Dr. Gandhi.
Thank you, Dr. Bhatia. Thank you for your kind words. Good morning, students. So, as Dr. Bhatia was discussing about the challenges that we are facing in terms of developing semiconductor as a big industry in India, as we all know that semiconductor is a backbone for the modern electronics. So we have to draw, in my opinion, we have to draw inference from the international other countries, like the smaller countries like Taiwan, Korea, in last decade or so, how they have developed this industry and boom their economy as a whole. So and also America, because there was a very close tie-up between government, the academia, and also from the uh, from the industry. So there is a kind of PPP, public-private partnership models they have followed, and they have followed a chip initiative in which they have incorporated the semiconductor as a subject in the academia. This is one of the important initiatives that India probably could take, incorporating this semiconductor in the educational institute, and also providing the vocational training, because until unless we have the skill development, it is hardly impossible to chase our dreams to be a global semiconductor hub in India. Today we are at 4 trillion economy in India, and we are the third largest economy in the world. And still we are lagging in the semiconductor. I mean, there are challenges, there are governance challenges. Obviously, there will be challenges if for any initiative. So this is one of the things which we can do for skill development. Also, there has to be training programs. Also, there has to be industry tie up with the academia, wherein you can always give certification programs to the students who want to pursue career in this semiconductor. One of the important thing is inclusivity, because if you see, India is number one in the population in the world. So we have to also train the other masses, like the women's, or the other underprivileged communities in India to this level, so that they can provide the skills for the development. Also, I belong to the infrastructure space, so infrastructure is also one of the important parameter for the development, and for the export of. If there is a production of semiconductor, their export is also one of the important parameters. So basically, I belong to the infrastructure space, so we have to produce a good supply chain, and also under the Prime Minister Gati Shakti, we have to also provide quick movement of the goods from one place to another. So these are the thoughts I have. Also, the government should have some initiatives and support to the industry, giving incentives, which in order to encourage, and this is one of the premier segment where we can do. Thank you.
Okay, thank you so much, Dr. Gandhi and Dr. Bhatia. Now I request Professor Manoj Saxena to give his view, and in the first round, and after that I will conclude something. I will say, as a panelist also, I will say something, and over to you, Dr. Saxena.
Am I audible?
No, we cannot hear you. It's not audible.
Am I audible? No, not yet. Can you hear me?
Very less intensity. Can you?
Am I audible now?
Yeah, it's bit better.
Okay. What I'll do is I'll be sharing my slides for the benefit of the students, and I hope the slides are visible to you. Can you see the slides? Are these slides visible to all of you? Okay, fine.
Yes.
Okay, thank
It's
you. Thank you
visible.
very much. Thank you very much, the panelist and the session chair for this. See, I've been part of the academia for more than 25 years, and my association with various professional bodies uh, has actually helped me in understanding the various challenges which an academia institute actually faces when we have to relate it with the startup ecosystem or the semiconductor mission of the government of India. And especially because the students, they study a lot of things related to smart manufacturing when We are talking about be it IoT, be it cloud computing, or be it AI and machine learning. These are the buzzwords which every student is interested and would like to work upon. But if you want to run on any of these applications, what the student has to understand is that you require a certain hardware. So we are talking about things which are related in advances in materials, devices, and structures, and we are talking about the semiconductor manufacturing for all those applications which are yet to be created. And these are essential for the economic, social, and security needs of the nation. Now, my fellow panelists have already introduced the relevance of semiconductor workforce development. So, I would like to cite two examples. One is of the US, where there is a huge gap between the economy and the requirements which have been created because of the enactment of the CHIPS Act. So, before the CHIPS Act, one can see that the requirement of the industry was entirely different. But once the CHIPS Act has been enacted, this has actually helped in increasing the requirement for the undergrad, postgrad, and PhD students, which are specially working in the area of semiconductor manufacturing and design. Now, India is not lacking behind from US in this regard, and Honorable Prime Minister has pushed a lot of schemes in the past 2 years in that direction, and the industry has also taken a lead in that regard. Be it Tata's, TCS, NXP, and other industries, they have come forward and have committed for a major investment towards the semiconductor manufacturing to boost the R&D efforts in India itself. But students, they have a tendency, what I perceive from my experience is that they are more interested towards software development and AI, generative AI, because they think that, okay, that's going to be the next buzzword and this is what the future is all about. But if I look it from the perspective from an electronics engineer, I see that there are a lot of challenges which the artificial intelligence or the generative AI is now putting up. The first is that if we talk about the data centers, there is a certain amount of power density requirement for these centers. And when we are trying to talk about the artificial intelligence training workloads, it is going to consume somewhere between 100 kilowatts or so. And if we try to see it in context of the generative AI, it actually triples. That is nearly 300 kilowatts or so. So there is a typical S curve which the semiconductor industry is currently changing upon. And if we look at the S curve, what we are trying to say is that everyone wants to use generative AI, but it is expensive, it's bulky, and it's not widely accepted. But times are going to change in the next year or so, and where we'll see that lot many persons are going to use this technology as well as in industry and academia. So that is going to put a lot of pressure on the semiconductor leaders and the industry setups, and new technology or innovations are required to meet up with the challenges which are associated with the handling, the power handling capabilities for the generative AI. So when we talk about the challenges which are associated with it, we also have to see that whenever we want to have these data transfers which are going to take place, you need a lot of R&D in the area of interconnects. So, students or the faculty members who are there in the audience, they can very well imagine that the requirements or the upgrades which are required, that was initially every 4 years. So you have to double up the speeds for interconnect in every 2 years. This is the pressure which is there with the introduction of this generative AI in the semiconductor manufacturing has pushed upon. So the whole electronics industry is has to go to the new levels of performance for this part. So I'll take up one example for the benefit of the students that the Intel, the new IC which they have proposed, they are based on two technologies. One is on ribbon FIPS and the other is a power via technologies. And both of them, they work on the very basic principles which most of the undergrad and the postgrad students have studied during their course of study. But this is the major gap. What we teach in academia and what is the requirements of industry. Now there, this gap is widening. So when a student graduates and would like to be hired for any industry, there you'll find that this gap is widening every 6 months. So if I look at from the semiconductor industry point of view, these are the various job openings or the career paths which are available. But for every career path, there has to be an associated a skill knowledge or the skills which are the student has to acquire for that. So for any of the positions of semiconductor engineers, process engineers, product engineers, or any of those things, two important aspects is that the knowledge of semiconductor devices, circuits, and systems, and then the second part comes in, which is when we talk about the development of new materials are there. Be it global foundries or be it Intel, IBM, the requirements are prima facie nearly same. So my recommendations for the students and for the higher education institutions is that the students must be involved in certain professional bodies where they get to know more updated information on real-time basis. And then in every higher education institutions, we should set up some sector-specific models or training centers. Now, depending upon the geographical needs of that particular state, we should try to identify the various centers. And then it may not be possible for every higher education institution to set up a semiconductor fab or a testing measurement center. So emphasis should be towards the electronic design automation or technology computer aided design simulation parts as to be made part of the core courses. And last and not the least is that there should be a seamless movement between the academia and industry, both for the students as well as for the faculty members. Well, these are my opening remarks, and I'll contribute as the panel discussion goes on. Thank you very much.
Thank you so much, Professor Saxena. You have covered broadly, very broadly, all the aspects, the importance of a skill, particularly in the aspect of the semiconductor. So, as far as the students or manpower are concerned, obviously what you mentioned, that students at this scenario are preferring towards computer science, AI, ML, everything. But at the same time, semiconductor areas are also having the scope in that area also. But you have to have some semiconductor knowledge as well. So those AI, ML can be applied in semiconductor process, product, everywhere that can be implemented. What Professor Saxena mentioned. So very good coverage. So that is a message for the students as well. And not only that, as all of us we mentioned, and it is very much important that fabrication, manufacturing of semiconductor devices is very cost intensive, and it is not everybody's cup of tea. And that's why I have given my experience that when we went through some of the interviews to recruit to some of the students for our projects in our institute, we have seen that they have good theoretical background knowledge, but whenever we have asked about some practical knowledge, hands-on, they don't have. And based on that experience, You will be glad to know that we introduced at that time, that is in fact before COVID pandemic, introduced 2 week hands-on training session, that is SIL, Semiconductor High Impact Learning Program. In 2 weeks, the students of having the general knowledge, background of semiconductor devices and the process, they can go through that 2 weeks hands-on training and have an overview how devices are gone from design to fabrication towards product. How wafer looks like, what photolithographic techniques are there, what are the processes are involved for the fabrication of the devices towards testing. So whatever we are using as chips, how chips are being fabricated, and after fabrication of the chips, how it can be tested in wafer level as well as in package level. All those, an overview at least, they can get. And we are glad to mention that because there is an issue of limitation of students, we cannot introduce in unlimited number of students in one batch. We give the exposure in each batch around 20 number of students. And we are now running 11th batch of SIL. And though the students are the final year BTech and MTech students are coming from all over India, all engineering colleges, so they are getting the exposure. So it is the 11th batch, so more than 200 manpower we have given the exposure, at least the overview of that one. And after that, it can be customized. So that is one thing. And that's why with the success of this program, we have proposed one program on development or creation of a center of excellence for this skill development with the support of state as well as central within the state itself, because as we are from CSIR series, so that is one of the national laboratories situated in Rajasthan, working in the area of electronics engineering, and as a responsibility or interest of our organization being within the state itself, that we are proposing that center of excellence on skill development in the area of semiconductor device fabrication, and that can go from design to fabrication testing, including ATMP and OSEC also. We have submitted the proposal. Now it is up to the government, state, and central to look after that, to check the feasibility of those things, everything. So we are proposing, and that is our idea mentioned, and particularly for the benefit of the students and major benefits for the industries as well. And from our institution side, we can say that that is the contribution from our side towards India Semiconductor Mission. And as you see, why the government has gone for the India Semiconductor Mission, if you see the semiconductor market, particularly for India, in 2022, when just before the announcement happened, the market was around 27 US billion dollar. And now the projected market for semiconductor only for India over the 10 years of time, the projected projected market is more than 270 US billion dollar, with CAGR more than 26%, which is havoc. And all those, there are so many challenges, obviously, but opportunities are also there. As it is very much cost oriented, the fabrication, government have given 3-4 schemes also. Those are including fabrication, fab lab for semiconductor, fab lab for display, ATMP, that is assembly testing, manufacturing, marking, and packaging. That means for some industries, those fabrication of chips devices may not be possible. So they can go for the only assembly, testing, marking, and packaging of those to make the systems. And OSAT also. That means outsourced semiconductor, whatever the semiconductor device or chips, they can get outsourced from outside, and after that they will go for the testing and subsequent system fabrication. So all those, if we see that initially the government was having the scheme of semiconductor fab and display fab, where 50% of the project cost was given by the government. The others are the compound semiconductor. Within the semiconductor itself, there are other quality of semiconductors which are compound semiconductor, and among those, gallium nitride and silicon carbide are the most important. And the semiconductor ATMPs for silicon photonics as well, sensors including MEMS. There are huge scope of different miniaturized semiconductor sensors in various applications, starting from electrical vehicle, automobile, power semiconductor, power chips. So many areas those are required. Design link initiatives as well. So government has given a scheme that for everybody the fabrication of a device may not be possible, but design is okay. And you see that most of the semiconductor industries globally, mostly they are design oriented. So they can make the design and they fabricate the device in different foundries. So there are very few foundries like TSMC in Taiwan, global foundries in USA, kind of thing. But there are so many design industries are there. But for the design also, you have to have the knowledge of fabrication so that you can design the fabrication compatible design. So that should be the design. There are so many softwares are there. Nowadays, commercial softwares are there. You can put any input and you can get the output values. But the design, your input parameters should be validated, should be as per your knowledge, what you are gaining through theory. And long-term strategy for supply chain and design and startup, IP partnership as well. So there are various opportunities because as I mentioned that for semiconductor device fabrication also, the raw material, all we are importing, starting from wafer, what are the chemicals we are using, very pure gases, everything. So the industry, there are huge opportunities for the industries also to look after that one, so that they can produce high quality materials, semiconductor fabrication compatible materials to be used during fabrication, wafers, gases, everything. And for the knowledge of, for the information of all of you, particularly for the students, I just mentioned that government also announced, in fact, Honorable Prime Minister online announced three units, semiconductor units on 14th of March this year. One fab lab, I think all of you have know, that has been established in Dholera in Gujarat. That is purely fab lab in association with TEPL, Tata Electronics Private Limited, with TSMC, Power Chip Semiconductor Manufacturing Corporation, Taiwan. And they have the capacity of 50,000 wafer per month. producing capability. In the area of various electrical vehicle, telecom, defense, automotive, display, consumer electronics, power electronics, and the projected budget is 91,000 crore. The second unit is semiconductor ATMP unit, and that is associated in association with Tata Semiconductor Assembly Test Private Limited. That is established in Morigao, Assam. That I mentioned, that is for ATMP, and the budget is around 27,000 crore, which is having the capacity of 48 million chips per day. That is for ATMP facility, not the fabrication. The third semiconductor ATMP unit for specialized chips, and that is established in also Sanand, Gujarat, with CG Power and Renesas Electronics, Japan, and Star Microelectronics, Thailand. And the areas also, the chips are, that is also ATMP in special chips for industrial, automotive, and power chip. The budget is more than 7,600 crore, and which is having the capacity of 15 million chips per day. So what thank you. So what we wanted to say, that there are challenges, but it is very much important, as we discussed. The market of semiconductor area is huge, and government is initiating so many things. So many states governments are creating opportunities in association with the center to create various facilities. But for the manpower, what we are thinking, that wherever the manpower is, the industry cannot get the manpower from their country. The manpower will be from our country itself. So huge opportunity is there, and take this opportunity for the as a job opportunity. They mentioned that all these only 3 units, they have the 20,000 high skill manpower opportunity for job, and above that more than 60,000 indirect jobs of that. So that is related to employment and job. And apart from that, if anybody is nowadays in this generation, many of you are very much interested with startup, creating startup by your own. So there are huge opportunities for the chemicals, wafers. Very few. Take only one raw material and go ahead. So with this, I just hand over to other panelists also if they have any additional comment, and after that we conclude.
Thank you,
Professor Pal. As Professor Paul said, that huge opportunities in this area of semiconductor manufacturing for the students, for the as a part of their employment, like IT industry, there will be a huge employment opportunities in this semiconductor area, manufacturing area. Government has taken some of the initiative to establish the fabrication lab at 3-4 places. Some of the specific training programs are also required. As Professor Pal said, that CSIR Siri is also given the proposal to the government for the students training of some crash courses that will be useful to know how the semiconductor manufacturing process done for fabrication of the chips and devices. Some of the more initiatives are also required, as suggested by Professor Paul, and in my view, government should start continuously in public PPP mode some
training
training
programs
programs
also
also
by some
by
private
some
partners
private
also
partners also
in this
in
particular
this particular
area. So
area. So
create
to
the
create the
awareness in the
awareness in the
students,
students,
because
because
there is
there is
a lack of
a lack of
awareness
awareness
about the
about the
opportunity in this
opportunity in
area.
this area.
So
So
students will
students
attract
will
more
attract
and
more
more,
and more,
attract
attract
more
more and more
to grab
to
this
grab this
opportunity.
opportunity.
So I
So
think
I think
we have started,
and
as all of
as
you
all
know,
of you know,
our country
our country
has
has
great
great
potentials.
potentials.
Who cannot
Who cannot
imagine in the
imagine in
UPI
the UPI
transactions
transactions
before five,
before
6 year
five,
back
6 year back
that we will
that
be
we
in
will
the
be in
number
the
one
number
in the
one
world?
in the world?
Now India
Now
is the
India is the
number
number
one
one
UPI
UPI
transaction.
transaction.
So
So
definitely,
definitely,
if we have
if we
started,
have started,
then
then
within three,
within
four
three,
year,
4 year,
we will
we
cope up
will cope
with the
up
world.
with the world.
And
And I
I
hope
hope
the great awareness will be generated
by
by the academicians, by the combined efforts of the government and
industries
industries to make this opportunity for our country also.
Thank you.
Thank you.
Thank you, Dr. Bhatia. So, my fellow panelist has covered all the aspects. So, as a closing remark, I would like to encourage all the students. There are immense possibilities and opportunities in this field. Nowadays, everyone is running behind AI and CS, but even in this semiconductor electronics field, there is an immense possibility and career opportunities which one should try and pursue. Government is supporting, government is in the right direction. So my personal feeling is we will come out as a key player in the international global market in this field. Thank you.
Thank you, Dr. Bhatia, and thank you, Dr. Gandhi. Professor Saxena, if you have any additional points to comment.
Okay, I hope I am audible now.
Yes.
Again. Okay, I just have listening to esteemed panel. I thought that let me share few things. Just quick view. I hope that this is my
Yes,
visible to all
visible,
of you.
visible.
Okay. So it's a great initiative of CSIR Siri Pelani that they are going to set up some training center for the benefit of the students. And till such time where this center is fully operational, I would urge upon the students to kindly go to these two websites. This is a Nano Hub initiative of Purdue University where they can get an access, a free access of learning the semiconductor process and device simulation. As you can see, this is a world map. And if I talk about India, that there are more than 5,000 users within India for this particular tool. Another initiative on a similar line is by Government of India. This is an Indian Science, Technology and Engineering Facilities map, which they call as iSTEM. So on this also, you will find that there are several softwares which a student can access right from their home tool. And for MEMS solution also, they can do some preliminary studies before they actually go to the fab. Without fabrication, without doing hands-on, nothing can be learned. But we should not wait till that opportunity is there with us. And last and not the least, I would urge upon Siri Pilani that if whenever this center opens up for the benefit of the students, please do partner with academic institutions where you give away the certificate of completion for recognizing the students that they have learned a semiconductor fabrication course. And this will be beneficial for the students whether they are going to apply for some jobs or for any postdoc or higher studies in that case. These are my closing remarks. Thank you. Thank you very
Okay,
much.
thank you so much. Thank you so much. You have included all the points, and as you very much noticed that one, that certification is very much required for them, and that will be very much useful, and in every aspect that can be done. So we have started an overview 2 weeks program, that is an overview kind of program, and this type of program may be customized, and at present that may not be possible at our institute because there are so many other projects we have to run. So that's why we propose this center of excellence specifically for skill development in various courses. The candidates may be in diploma level, maybe in BTech, MTech level. All of them have the opportunities if you think in semiconductor and related electronics. So that's why it is on design, it is on fabrication of semiconductors, associated ATMP, OSAT, everything is included in that center of excellence, and from our institute side, we will have our full support to that center of excellence once it is established. So those things, and also I just repeat what the panelist also mentioned, that frequent interaction with industries is very much required. What we thought this is very much required. That's why the feedback from the industry we have, and according to that we can carry forward our research, which one of our panelists also mentioned. Not only theoretical background on semiconductor and electronics is very much important, but it should not be within the pen and paper itself. It should not be in the publication itself. It should be product oriented. It should be technology oriented, so that it will see the market. And what I have seen, that TEK Connect and TEK, they have evaluated T for technology, E for export, and K for knowledge, and they are also very much interrelated, and they are independently important and very much correlated. So connection within that aspect is also very much required. So with few points, I think some of the major points have already been scribed, and those things will be forwarded to authority for that final discussion. I, on behalf of myself, I thank all the panelists for giving the your opportunity and your support for this. And from the panelists, I thank all the audience for listening with a great attention. And from the panelists, I thank the organizer giving this opportunity to put this on table. This much very much important point. Thank you all.
I would like to request among the audience, if you want to ask any question. Any question from audience side?
Yes.
Sir, as a student from CS background, we have seen the shift from traditional method of computing to modern technologies like AI and ML is now being integrated in our course, and the semiconductor, which is more primarily kind of thing of electrical engineering. So, how can a student from CS background can shift to these like complexities, as you have just said, that the theoretical knowledge of semiconductor is quite necessary to get into the core industry of semiconductor. So, how is it possible?
Yeah. My personal opinion is that at this situation, AIML is coming, and all the students, you are using the softwares as a toolbox. So if you use it as a toolbox, then it is very difficult to go into the background of that. So that is one thing. So whatever you do, why you are doing, you think along with that. So that will, so in some of the cases, in very deep into that problem, that may not be possible, going into that may not be possible. But what you are doing, why you are doing. So you think of that, and it will serve to some extent purpose. And obviously, what you mentioned, that semiconductor is not new thing. That is very much old thing. And AI/ML is also not very much new thing. That was also earlier. We are using as application. We can use this AI/ML in any platform.
Any more questions?
Any more points I missed from the panelists? If you want to say something,
That's okay.
Professor Saxena, you want to add something?
No, perfectly fine.
Okay.
Sir, you told us that semiconductor is also important and we should study semiconductor with our courses. I want to ask that our courses as a BTech student, we have a very hectic schedule of studying and then doing assignments and projects. So, how can we manage to study semiconductor with our BTech studies also?
I am not saying that semiconductor is the only important subject to study. I have said semiconductor is one of the most important subjects, and it is now giving so many opportunities. And being in the electronics, I think whenever you have covered some of your courses, it is the electronics is the area. It is having the privilege to be get associated with various interdisciplinary areas, isn't it? So that advantage you should take. So what I am saying, that not only, I am not saying that you have to focus on semiconductor only. No.
No, sir, I'm not asking
But
that.
the thing is, you have in your BTech courses, some of the courses are there. I think that maybe in third year, somewhere in sixth semester or somewhere.
Let me answer. You are
You are saying that you already having a very hectic schedule. So how you will move towards the semiconductor manufacturing? I would like to give the answer. Apart from your hectic academic schedule, you everybody want to learn some of the languages, some of the AI tools, some of the which are the cutting edge technologies. So that is also a cutting edge technologies which is having very huge opportunities in the future for India perspective. So like other languages, you want to learn the Python, if you want to go into the robotics area. However, your engineering branch is mechanical branch or computer science branch or anybody, but you want some more apart from your basic curriculum. So this is also an emerging area for your future perspective. So you can focus on these areas also apart from your curriculum. Due to the ample amount of opportunities. जैसे आप एडिशनल एड ऑन कोर्स भी करते हैं, जहाँ पे आप अपॉर्चुनिटी देखते हैं. कोई लैंग्वेज आपको नई सीखनी है, तो करिकुलम तो वही रहता है. बट for this purpose, I think some of the universities, our university also has been started some open elective subjects. So we have introduced some open elective subjects as the semiconductor fabrication process, VLSI design flow. Anybody who has the branch of civil branch, because all the branches are, I think, interdisciplinary now. सारी branches interdisciplinary हैं. तो open elective we have introduced so that student can select one of their subject apart from core subject as a semiconductor manufacturing. So there will be no extra burden on you.
One more
one more point to add from the industry point of view. Now, industries in this new era, we are moving towards certification. The basic course is also important, like degree, MTech, BTech. But we are now at the era where extra certification is required in whatever field you want to pursue, irrespective of your basic course. So, if you have an additional certification, if you're interested in semiconductors or electronics, if you have extra certification, then it will help in your career growth. Thank you.
Yeah, two very important points we discussed. One is certification you are getting. So if you have interest, you can put on that. The other thing is just like clubs. You have to in your engineering colleges, robotics club, AI clubs, music club, other so many clubs are there. So if you can create semiconductor clubs as well. That is one thing, but that is additional in addition to your curriculum. But to what Dr. Bhatia mentioned, that if it is being introduced within the code itself, that open elective, so within you can select any of your choice that elective, and according to that you can go ahead. So that will be within your course itself. You can have the credit. You should not have an extra burden for that also. So that is great. So whatever, obviously, time to time from the university side also, the updating of the courses, all these things, I think it is going to happen. In university is looking after that, I understand, and that's why frequent interaction with industry is very much also important. Professor Saxena, if you want to add.
I just have one quick suggestion for the young student who asked this question. Well, see, we always say the will mange more. So if you want a success to be there in your professional career, you have to put an extra effort. I'll give one suggestion. Whenever you have to do some projects, try to have interdisciplinary projects during the semester. You talk to your students of the other courses and then try to have projects with them. For the benefit of the students who are in the audience, maybe from electronics and CS background, I'm just sharing, I just downloaded one article which relates the application of machine learning in the device circuit co-optimization. And this is the kind of approach we should try to inculcate amongst the students, and the students should also learn. But try to apply a technique which you have learned in your disciplines to the other disciplines. Unless and until we develop this transdisciplinary approach towards the project making or dissertation, the suitability in terms of industry, you will be lacking. So this is my suggestion from my side.
Very nice suggestion, and that's what I also mentioned, that use AI/ML as application, and that can be applied in various domains. So it's not that AI/ML is not important. You can use any areas.
Thank you, sir.
Okay.
Any more questions?
Regarding the manufacturing processes of the various semiconductors, what should be our primary focus, like trying to catch up with other countries on microprocessors and like let's say ARM and x86, or trying to develop a niche in, let's say, specific sensors or the modules that work with them?
So at this stage, I think it is not in your domain. That what should we start? Industry is seeing the market, and wherever the possibilities are there, wherever the market is there, they will jump into that. But it is not that that field and is giving the allied all other association as well. So at present, just like what we mentioned, that the semiconductor and allied industries, and semiconductor is a very much cost incentive. So industries may not be ready to invest 10 billion, 10 to 20 billion US dollar at one time. That may not be possible. So that's why industry may start from ATMP, OSAT kind of thing. That means they can, what most of the industries are now doing in India. They are importing the chips, they are going for the assembly, testing, packaging, and making the system kind of thing. And government is also promoting to that also. So that depends on company to company. Whatever the big companies, they can think of that manpower is available, good manpower is available in India. They can go for the establishment of foundries, device fabrication. The smaller companies, they can go for the designs also. Smaller other industries, they can go for ATMP, OSAT kind of thing. But possibilities are everywhere.
I have one question to Alok sir. Alok sir. Yes, sir. As mostly these are students and they are all pursuing their career. So, as an industry expert, what suggestion you can give to the students, sir? This is a common because to maximum utilize this platform. So, how should they prepare for the industry? What are the recipes?
If I look back now, 25 years ago, I was also a student of BTEK when I did MTech. So basically, what I have understood working for 25 years now in the industry, whatever is your interest field, I'm going, aside this topic of semiconductor, whatever is your interest field, you need to recognize that in the initial 2-3 years of your work, because when you pass out, you don't know what is actually what are the field available, what is your interest. But in 3-4 years, you try to recognize what is your field, and then in that you try to pursue your career. And then certifications, there are various certifications, skill enhancement, that has to be a part of parcel of your career, because you cannot stick to one thing, because nowadays technology, knowledge, everything is so evolving. So you have to be on the up to mark with the trends. So keep on updating yourself, and then select one field after 2-3 years of your experience, pursue in that field. Don't jump from here and there. That could create a mess at the end, So this is my personal practical experience that I had in so many years. Thank you.
Thank you to the moderator of this panel discussion, Dr. Suchandan Pal, along with all the esteemed panelists for sharing your valuable insight and expertise on the latest advancement, including the revolution and challenges in semiconductor technology. Sir, we are quite grateful to get the insight into the semiconductor. You have highlighted number of concerns like for the semiconductor, we used to depend on other countries, and recently we are facing the challenge to fill the gap of that manufacturing of semiconductor and to gain some skilled workforce. And you have given some solutions related to that, to add some courses at the initial level, like at the time of diploma level. And there is a need to advance the methodology of research, like we should be more into the practical on-device research environment that should be needed for the field of the semiconductor. More suggestions that we have received from the panelists to get good certification from the industry side, and to encourage the students to take trainings and crash courses in the field of the electronics and semiconductor. One of the panelists have also tells us the scope of semiconductor in terms of job, that is not only in the manufacturing but also in the design. And you have also highlighted the impact of generative AI as the generative AI application propelling the corresponding demand of computational power. And we can say that AI can leverage the field of electronics at the next level if we use it rightly. And in the end, like our panelists have great quoted that awareness is the real key of all opportunities. So we would like to thank you to all the esteemed panelists along with the respected moderator for taking out their time from your busy schedule and marking this spectacular session with your glorious presence. Thank you so much, sir. We would also like to
Thank you so much for nicely summarized all the topics. Thank you so much, and we thank all the audience. It was supposed to be end by 12 o'clock. Now it is 12:45. So they have great interest on their subject. Thanks all.
We would also like to add a huge thank to all the coordinators, audience, organizing team, the technocrat and the academician for giving the audience this stack space and to think more about the semiconductor. So thank you everyone. Now I request the audience to please move to the OAT for the further program. Thank you.
एक बार एक बार वो तो खुद ही चल
रिकॉर्डिंग तो आ जाती है नहीं नहीं रिकॉर्ड करनी नहीं थी वैसे भी आ जाएगी
लाइव
रिकॉर्डिंग तो चाहिए नहीं थी ना ये तो
हेलो अरे एक बार आओ ना सेशन और हो गए सामान एक बार आ जाओ
I request the respected panelists and the moderator for the group photograph. Please, sir.
आ जाओ एक बार भेजो किसी को ना किसकी